Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
Okay, so Pam, quite a while back, we did an episode about the doubling and halving strategy for multiplication, right?
Which
That's
we
one of our
both
episodes.
totally love, right? We love. Uh-huh.
And I think that in that episode, we talked about how the name itself, that we call it doubling and halving, is a little bit too constraining. Let me give the listeners just an example. Let's say that you're given a problem like 50 times 16. Okay. You can create an equivalent problem that might be easier to solve by doubling one of the factors and halving the other factor. So in this example, you could double the 50 to make 100 and half the 16 to make 8. And then you have a new equivalent problem of 100 times 8, which is really pretty slick, right?
Yeah,
very
nice.
The problem is that's not just true for doubling and halving. You can also triple one dimension and find a third of the other, or quadruple one dimension and find a fourth of the other, and on and on. And so for years now,
well, in fact, can I just do that with that problem?
Sure.
Because you got to 100 times 8, but we could keep going. We could go to 200 times 4.
Yep.
We could keep going to, I could do 400 times 2. Yep. And yea, verily, we could even keep going to 800 times 1.
Yeah.
Which means we could have gone from the 50, we could have quadrupled the 50 to 200 and divided the 16 by 4 to 4.
Yep.
And so on, like that. That's an example of quadrupling, quartering, or times 8 divided by 8. Mm-hmm. Like 50 times 8 to get the 400, and 16 divided by 8 to get the 2. Yeah. So there's an example. Keep going.
So for years, you've kind of lamented a little bit about how the name that even you and I give it is a little bit troublesome because it's maybe not all encompassing enough. And you have promised that if anyone can come up with a name that's better than doubling and halving, maybe more, it's mathematical, but it's slick, that I'm pretty sure that I've heard you say a number of times that you would send them a free shirt.
A free Math is Figureoutable shirt. Ow. Yeah. Mm-hmm.
So recently we had a listener who sent in a suggestion, and this is from Alexandra Farrell. And she writes, I'm currently doing your multiplication workshop. Yay.
Yeah. Wait, thanks for taking the workshop. Glad you're loving it. Yep.
She does it evenings while she's cleaning the kitchen and making funny teacher t-shirts. And she says, I'm a huge podcast fan. Woo. Don't stop those. They bring light to my Tuesdays. Thanks, Alex. I've been thinking about the doubling and halving name, especially when I walk my dog. I think more of switching the factors out. And she gives an example of 28 times 5, which is 7 times 4 times 5, which then could be 7 times 20. And she says, maybe...
Well, that was kind of fast. Can I say that again?
Sure.
So 28 times 5. The 28 is 7 times 4.
Mm-hmm.
So still times 5. And then she pulled the 4 times 5 together to get 20.
Yep.
Which leaves the 7 hanging over. Yep. Okay, so she's thinking about 28 times 5 as the equivalent problem 7 times 20. Got it.
Sure.
Okay.
Yep.
Thanks.
And she says, maybe you could call it the factor switch.
Ooh.
Factor switch. So, Pam, What
Huh.
say you? What do you think of Alexandra's name, factor switch?
Well, so Kim, I'm also kind of curious to know what you think about it.
Okay.
Do you want to start?
Sure. So I have to say that I like it a lot more than many other names that we have been
Yes. Yeah.
suggested
We
over the
we have lots
years.
of people suggest things that we don't bring on the podcast, right?
Factor
Like,
switch.
so that says something here that we're actually
So
talking about it. Uh-huh.
I don't think I love factor switch, but
Okay.
in the same way that I don't love doubling and halving. It just
Similar.
mm, how do I say this? It just
Is
doesn't sit quite right with me.
is it
And I'm not
because so
sure factor switch.
well
Like
and
switch in what way? It's moving from one factor to another. It's decomposing and then recomposing.
yeah.
Um I don't hate it.
Hmm.
I have
Hmm.
struggled a little bit about this because I almost want to just say it's the associative property at work, but that's a little too broad. It doesn't.
I believe Kathy Fosno
Oh, does
says that.
she?
She's like, it's
Me
the
and Kathy,
she
we're on the
does. She's
same.
like
It's too broad.
she's like, it's well, it's interesting because when my numeracy was bad, which was for a very long time, and I was reading her work and she said, see, it's the associate property. I was like, huh?
Yeah.
Like I could, and I to be clear, she didn't, at least with the part that I was reading, there wasn't a lot of let me write out the factors
Yes.
and
Unpack
then
it.
unpack it so I can see the
Hmm.
parentheses shift and I
Yes.
can actually see the associate property. But when she
Yeah.
would say, see, doubling having is the associate property, I had
Yes.
I could not, like, nope,
Yeah.
nope, not at
Well,
all.
and I feel like we would have to make some assumptions about kids knowing that name that is a little bit too yeah.
It's a long, big
You
word,
and I
right?
yeah,
Yeah,
you and I are not super big on kids must know the name associated property. We want them to use it,
right,
right?
exactly. And
Um
so that's
so
probably where, oh, go ahead. I didn't mean to,
yeah, I was just going to say that's kind of where I am with the factor switch thing. Like if they don't look at a problem like her example, I don't remember what it was now, but 28 times 5,
yeah.
if they don't look at 28 and automatically go, "Oh, that's 7 times 4."
Hmm. Well, or we could even
It almost
we
feels like
we could change her example slightly because she's doing really a factor switch. But if we kept that
yeah.
28 times 5 and made it be 14 times 2 times 5, so 14
Yes.
times 2 is the 28. And for listeners, what I meant by the parentheses in the associated property, so I've written 28 times 5, and then under it, I've written 14 times 2 in parentheses times
Uh-huh.
5 because the 14 times 2
Yep.
is at 28. And then
Yep.
the next line I would write 14 times 2 times 5 like again, but I would put the parentheses now around the 2 times 5. So
Yes.
I've got 14 times 2 times 5. And that
Yeah.
becomes 14 times 10. That would be
Yeah.
a true double half, right?
Yeah.
Because we're
She's
doubling
using
and halving.
quadrupling.
She
Mhm.
was quadrupling and quartering, right? No.
Mhm.
Yes? Yeah, had to think back what she did. Looking at my double half. So she was doing much more the kind of advanced example, the
Sure.
more general. That's what I wanted. The more general
Yes.
example where, ooh, I could pull the nicest factor out and reassociate it to
Yep.
with a different factor. I could switch the nicest factor to make, like a really slick problem. That is definitely a higher, more complicated, more sophisticated strategy. So part of what Kim and I are looking for when I've given this, or what I'm looking for when I've given this challenge to say, hey, come up with a better name. And so it's kind of not fair, Alexander, because the what I'm looking for is something that fits when kids start doubling and halving. And when kids
Mhm.
start doubling, well, I want it to fit then, and then I want it to grow with the student. And that's part of why I
Mhm.
don't like doubling and halving. Doubling and halving fits really well with the young students. I was working with young students who are just beginning to think about multiplication. We were doing a problem string, and it was something like 2 times 8, and I was doing it on an open number line, so I had 2 jumps of 8 with 16, and then the next problem was 4 times 8, and there were kids that were saying, well, I can just think about 2 of those 16s. And I'm like, why can you think about 2 16s? The problem's 4 times 8. And they're like, well, because those 2 8s are in that 16, and so I can, if the group is twice as big, I only need half as many of them. Bam! They're really messing right in that moment. Now, they don't have down, they haven't like constructed completely doubling and halving, but it's a brilliant beginning, and we can build on that as they sort of group the groups together, and they're thinking about, well, I can think about if I have a group that's twice as big, I only need half as many of those groups. We would obviously want to build that with an open array as well, with an area model. But anyway, that's why I still might send Alex a shirt, but
That would be
but I'm
lovely.
so yay, Alex gets a shirt. But I'm probably not going to switch names yet.
Yeah.
What we might
Yeah.
do, what I'm starting to consider, is that maybe I'm going to start encouraging teachers to let the name doubling and having kind of grow up
Yeah.
with the students. And so maybe doubling and having becomes something like using the associative property or the factor switch, or what I've called flexible factoring. So actually, if you think about our major strategies free ebook download, the last multiplication strategy that we would list, the most sophisticated, the most multiplicative of the multiplication strategies, is what I call flexible factoring, which I think is what Alexander is calling factor switch.
Yep.
Yeah.
Yep.
Yeah.
Yep.
There you go.
All right. So for the last few weeks, we've been sharing our thinking about the over strategy, a totally different strategy.
I'm just totally laughing
We're gonna
because we just went on and on about that. And that's not even the topic of today's podcast. So
It's
hold on
what
tight,
we
everybody.
do.
This one might be a little longer. All right.
Oh, goodness. So 2 weeks ago, we talked about addition, and last week with subtraction. And so this week, let's tackle a little bit of multiplication.
Let's go over. Let's go over on multiplication.
Okay, so this week, Pam, I'm going to give you some problems. But before we dive into a problem string, let's give the listeners a chance to think about a problem. And this problem is 99 times 79.
Okay.
So 99 times 79. Go ahead and pause the podcast and think about that problem. And then when you're ready, come on back and we will have Pam talk about her thinking.
Dun, dun, dun.
All right, Pamela, are you ready?
I am so ready. Bring it on, Kimberly.
Okay. All right. Your first problem is 8 times 8.
8 times 8. 8 times 8 is actually a fact a lot of kids know. 8 times 8 is 64.
Okay.
Cool.
8 times 64.
Okay.
All right. Your next problem is 80 times 8.
So we have this nice times 10 thing. So if I scale up 8 times to 80, there's times 10. I can scale it to 64 times 10, which is 64 tens or 640. But I'm starting to think a little spatially. So I've actually just drawn an 8 by 8 and I've labeled the area as 64, 8 by 8 rectangle. And then next to it, or underneath it actually, I've drawn a really tall 80 by 8. So it has the same width, but it's 10 times deep, 10 times tall, an 80 by 8, and that area is 640.
Okay, nice. Your next problem is 79 times 8.
So I only need 79 eighths. So before I had drawn that 80 by 8, I had drawn 80 eighths, but I only need 79 eighths. So I'm going to hack off just at the very end there. I'm going to cut off one of those groups of 8. And so 640 minus 8 is 632.
Okay. Next one.
Okay.
What about 100 times 79?
100 times 79, I can also think about as 79 hundredths. And so 79 hundredths is the name 79, or is the 7900. It is the number 7900 or 7900.
Okay. 99 times 79.
Oh, so if I've got 179s, I might draw that as this like really tall 100 by not as wide 79. 100 by 79. I've got 100 groups of 79. So it's almost like if I'm drawing the groups on that rectangular array, on that area model, I would draw a line across the top to kind of cut off a group of 79. There's one group of 79, and then underneath that, I would do another group of 79. So I'm kind of drawing a bunch of horizontal lines now to kind of chunk off these groups. One group of 79, two groups of 79, three groups of 79.
They're stacked on top of each other.
All stacked on top of each other, making this rectangle, completed rectangle. And if I were to keep doing that, but I'm going to skip all the middle, and I'm going to go all the way to the bottom, and I'm going to go, well, there's the 98th group of 99, and the very last group would be the 99th group of, I said 89, 79. The very last group of 79, I would have the 100th group of 79. And so that very last one would be the 100th group, but I don't need 100. You gave me the problem 99, 79. So I'm going to cut off that last group of 79 to be just 99 of them. And so now I'm thinking about what is that total area of 7,900 subtract 79. That would be 7,800 and 21.
So I'm going to pause you for just a second.
Yeah.
How did you know 7,821?
Yeah. So literally, I wrote down 7,900. I already had that from the problem before,
Mm-hmm.
minus
Yep.
79. And then
Yep.
I wrote down 7,800
Mm-hmm.
because I knew once I subtracted 79, I had to go below that 900. Because
Yep.
I was at 7,900. I know I'm subtracting something within 100. So I'm going to
Yep.
be in the 7,800s. And
Yep.
then I said to myself, what's the partner of 79 to 100? 21.
Yes. It's almost like within a 7,900, there's a 7,800 and an extra 100.
Mm-hmm.
And you
Mm-hmm.
just play I have you need with that last 100.
Oh, that's
Very
very well
nice.
said. In fact, sometimes I'll model it that way. I'll draw on the
Uh-huh.
board a number line, and I'll put on the left-hand side 7,800, and on the
Uh-huh.
right-hand side 7,900, and I'll say, okay, what we're trying to do is subtract 79. So I'll draw a bubble a jump that looks about 80-ish,
Uh-huh.
and I'll say, so I'm looking for this other bit, right? I'm looking for this bit
Mm-hmm.
between 7,800 and 7,900, and that
Mm-hmm.
little bit to get me up to that jump of 79. Oh, that's the partner of 79 to 100. Bam. Well,
Mm-hmm.
if I can think about that partner, then I'm good.
Yeah, and you and I play I have you need often, and so you just know that partner. But if you didn't know that partner, the minus 79 could have been really nicely what we talked about
Oh,
last
last
week.
week. Nice.
Yeah.
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 Like subtract 80. So
Yep.
7,900 subtract 80 would be 7,820. But I
Mm-hmm.
subtracted too much. How much too much? Just one too much. So
Yeah.
pop back up that one, 7,821. Nice. Oh, yeah.
There
That's
you go.
good
All
connecting
right.
to last week. I like it.
You ready for your next problem?
Yeah, go ahead. There's another
Okay.
problem? Okay.
Yeah. Just a few more.
Well, because,
What
sorry,
about
before you go on, because that's the problem we started with, right? 99 times 79.
Oh yeah.
And
Yeah,
so
yeah,
you
yeah.
stuck
Good
me in
call.
a place where I was thinking over. And so I was able to sort of
Mm-hmm.
think over and kind of solve it that way. Okay.
All right. 1/10 times 79. 0.1 times
Oh,
79.
that's interesting. Because you said 1/10, I actually wrote the fraction 1 divided by 10.
Oh, sorry about that.
No, it's okay. I mean, I could think about it either way, right? A
Yep.
tenth of 79 is 7.9. It's 79 divided by 10. And just like I can think of 70 divided by 10 as 7, then I can think about 9 divided by 10 as 9/10. So that's 7 and 9/10 or 7.9.
All right. Last
Okay.
problem. 99 and 9/10, 99.9 times 79.
Oh, now it almost makes me wish I was on a ratio table. Let's see. I know
Oh.
what 99 times 79 is because we had that before. That was 7,821. So I really just need 9/10 of a 79. And luckily, oh, no, that's not what I want to do. I could find 9/10 of 79, but I don't have that. My bad. Pam, we're doing an overstring. Why aren't you thinking over? Well, I wasn't till now, but I am now. Do you like listening to me think out loud? So
It's real life.
99.9 is almost 100. Since I know
Yeah.
179s is 7,900, I'm just going to get rid of a tenth of 79, which was 7.9. So now I've got 7,900 minus 7.9. I'm going to think about that as 7,900 minus 8. So
Yep.
7,900 minus 8. Now, there's some place value happening right here in my head. I've got to think about
Yep.
7,900 minus 8. That's 7,892.
Yep.
But I subtracted a bit too much. How much too much? Just a tenth. So I'm going to tack that tenth back on. So my answer is 7,892 and 1/10, 0.1.
Nice.
You think?
Nice. Yeah. So much easier, right? Than a traditional
I
algorithm
mean,
of
so much more
99.9 times.
meaningful.
Oh my gosh.
And all the place value that I just used, place value, now place labeling,
Yeah.
but where I actually had to think about the values
Yeah.
involved. And check it out. I would submit that the steps I just did, you could keep track of everything I just did, and maybe it might be the same. Now I still think it's fewer. I think it's more efficient than the traditional algorithm, but more importantly, I'm using multiplicative reasoning. I'm helping my
Yeah.
brain think more and more multiplicatively, get better at those relationships. And then my brain just gets more dense. I just
Yeah.
have this better, more sophisticated, more grown up, more mature, more dense. I
Yeah.
think a lot more connections become more a natural outcome for me that I can use when I'm solving.
Well,
Yeah, go ahead.
Yeah, and I love the fact that you were going to solve it one way for a minute, and then
Yep.
no, for real, because then you were like, "Wait a second, I know something that's gonna be even slicker."
Mm,
And that's what we want for our kids, right? We want them to go, "I'm gonna look at these numbers, I'm gonna think I'm gonna do something," and then go, "Wait a second, I know something else." The I know something else is the really cool part that we want for kids, choices.
choices. Oh, I'm so glad you said that. Yes. Yes. If we want to really create kids who are
Mhm.
mathematizing people have choices and they play
Yep.
around with relationships and they choose the one that is slicker for them that day based on what's pinging for them that day.
Mhm.
And the only way we
Mhm.
can have that happen is when we have choices, when we own. That's
Yep.
why I was so excited about being dense, right? That's
Yeah.
that's that's what dense means. I have multiple connections, multiple relationships I can rely on, I can go to, and use one. Thanks for thinking that was an
Yeah.
okay move. Hey, and
Yeah.
thanks for giving me the permission. I remember the day. I remember where I was standing when you said so you solved a problem, and I was like, whoa, 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 whoa. Tell me what you just did. And you were like, well, I thought about this and I thought about that. And then I thought about this. And I was like, that was the best. And I was like, you don't just know the best way right off the bat. And you laughed right at me. you're like, you were
Oh,
like,
sorry.
of course I don't. I play around with the relationships.
Yeah.
That freed me up to know that's what mathy people do. And I can
Yeah.
be mathy too. Y'all,
Yeah.
we can all be mathy too. It's not about knowing the thing right off the bat. It's about using what
Right.
you know, solving the problem, seeking for clever, efficient strategies. That's mathematizing.
Yep. Yep.
Love it. So, where does over fit in multiplication? Well, actually, pretty soon. Over is one of the first strategies. Once we get kids solving problems using partial products, we really quickly go to smart partial products. And one of those smart partial products is the over strategy. We want kids
Yes.
thinking a little bit too much and then hacking off that little bit of area. It's the place where we tend to use the area model more. And then we move to a
Yep.
ratio table. So let me just say that we use the area model or the open array to help kids build a spatial sense of getting rid of that
Mhm.
extra group. It also
Mhm.
simultaneously helps kids actually learn what area is, that it's not just this procedural. Was that the one where I multiply or that one where I add the sides together? Like, it's like area. Like we actually have to like own what area is so we can develop that spatial sense. Soon after that, we want kids really messing with this idea, or as we're doing that, we want kids messing with the over strategy. That is a partial product. It's a kind of smart partial product where they go a bit too much and hack it off. It's also brilliant because we can model that with the distributive property, with equations. So it's super early. We want kids messing with the over strategy. Now, in this problem string today, we went all the way to multiplying by tenths. We're not suggesting that you're doing that early with students. We just wanted to show you how versatile it is. Y'all, look at that problem. 99.9 times 79. Oh, yeah. And we can get much more complicated numbers. But that was a 3-digit by 2-digit multiplication with decimals, but
Right.
in a few steps, thinking and reasoning multiplicatively. So that's where over sort of fits in with a hierarchy. And so many of our leaders are saying, whoa, I'm so glad that you gave us this free ebook that outlines that hierarchy. So many of the
Yes.
leaders in our support system are just like over the top using it with their teachers. So we thought we'd tell you that link again. Mathisforgettable.com/big is where you can
Mhm.
download our what's it called again?
Hierarchy, ebook?
Yeah, the major strategies ebook. Thank you. So check that out. You might have noticed that I talked about using the area model so I can take off that group. Modeling is super, super important. And also notice the place value that comes out when we have to think about if I have this clunker problem like 99.9 times 79, what do I know? And what can I use? Ooh, I'm thinking about numbers that are close to it. And by doing that, that sort of sense of neighborhood and nearness, those are major big ideas in mathematics. That's getting at place value. So super, super cool. Um,
Yep.
Let me just mention one other thing. If you have kids that are stuck in what we call dumb partial products, one of the things we want to encourage you to do is really think hard about this over strategy and help your kids, help your students, help yourself move into smart partial products. And the over strategy is one of those smart partial products. So if you're doing a 4 chunker every time you look at a 2 by 2 multiplication and you draw a square, y'all, The chances that those 2 by 2 numbers actually represent a square and not a rectangle are pretty small.
Yes.
So you should be drawing a rectangle. And then if you're chunking it into 4 chunks every time, it's always the place value partial products. May we invite you, please consider the over strategy as a next move that you could make to really be mathematizing, thinking multiplicatively about those multiplication problems, not getting stuck in turning multiplication into a different algorithm. It's not about steps. It's about really reasoning using relationships.
Yeah, absolutely. If you've been tuning in for the last couple of weeks and you've not already snagged the free downloads that we've been mentioning, you are missing out. You'll want to check out this great resource for example problems and visuals for how you can model represent the over strategy for yourself and for your students. You can find this one I'm mentioning now in the show notes or at mathisfigureoutable.com/over.
Because it's over.
Yeah.
Great over strategy, and this podcast is over. So thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.